Welcome. We're going to talk about statistics today, and we're going to start by kind of talking about statistical and critical thinking. So when we're talking about statistics, there are some things we kind of want to look at. So data are the collection of observations such as measurements, survey responses, etc. So that's your data. Statistics is the science of planning studies and experiments, obtaining data and organizing, summarizing, presenting, analyzing, and interpreting those data and then drawing conclusions based on them. Population is the complete collection of all measurements or data that is being considered. It's the kind of the total. It's everything you're looking at. So a census is the collection of data from every member of the population. A sample is a sub-collection of members selected from the population. So these are just kind of some definitions that we want to kind of look at. So what we're going to now talk about is kind of this backdrop of statistics. So the first thing is we're going to talk about prepare. Okay? So what you're going to do is you're going to prepare. So the context. What did the data represent? What is the goal of the study? Okay, so that's the context. Does it have meaning? The source of the data. Are the data from a source with a special interest? Did this data come from something where they're hoping to gain favorable information? What is the source of your data? Sampling the method. Were the data collected in a way that is unbiased? A lot of times we collect data and we want to collect data that kind of is either pro something or against something. In that case, that sampling method has bias in it. It's actually already organized in a way that would cause you to have a favorable result or an unfavorable result, depending on what you want. So this is when you're preparing. You want to have data that is unbiased. It's collected in not from a source that has a special interest. Okay. Once we collect that data, we're then going to analyze it. Okay. So we're going to prepare. We're going to gather. We're going to prepare. And then we're going to analyze. First thing is we're going to graph that data. So we're going to get a graph of that data. We're going to look at it. We're going to explore the data. Are there any outliers? Are there any extremes that are kind of changing some of our statistics? So what are the outliers? Outliers can be very, very important. What important statistics summarize the data? The mean, the standard deviation, potentially some of those other things. So what are some important statistics that summarize that data? How are the data distributed? Okay. Are there missing data? Do we have a big chunk that's missing? If we're taking data from an age groups, is there one age group that doesn't have very much data or is very limited? Or is there one age group that has a lot? Did many of the selected subjects refuse to respond? If I gave out a survey to my high school students and none of the seniors responded, is there a group that did not respond? 3, we're going to apply statistical methods. So under that is we're going to use a technology to obtain results. Okay? So once we've prepared our data, we've analyzed our data, now we're going to conclude. We're going to actually make some conclusions. Significance. Okay? Significance. Is this a significance? Do the results have a statistical significance? Is there a measurement here that is mathematically, statistically right? Okay. Do the right results have a practical significance? Do these go hand in hand? Not necessarily. It could be a very statistical significant, have statistical significance, but not be very practical. So we want to be able to answer both of these questions. Okay. And then when we're talking about that, we want to actually talk about analyzing data potential pitfalls. So we're going to kind of go over some pitfalls to avoid. So misleading conclusions, okay? So we want to make sure that when we're presenting our data, we're not using terminology that is going to confuse our reader. We want to make sure that we use clear conclusions that the reader can understand. They shouldn't have to have a degree in statistics to be able to understand what you're trying to get at. You report your data instead of what's measured. So you're just reporting the data. Loaded questions. This is very unique when you're coming up with a survey. You got to make sure that your questions are conveying what you want to ask, not having loaded questions. You know, an example of that might be something, should the president have the line item veto to eliminate waste? Well, most people are going to say yes in that, right? He should be able to eliminate waste out of it. Okay, but that's a loaded question. The order of your questions. Order matters in how you present your questions. So make sure that your order is in such a way that you can kind of eliminate some of that problems. Non-responses. We've kind of talked about this. So that occurs when someone either refuses to respond to a survey question or is unavailable. Okay. And then percentages. Be careful about percentages. Percentages can be very misleading. I'm sure you guys have seen ads where they say, if you buy our product, we will, increase your stamina by 400%. Well, if you buy our car anti-theft, we have a 400% decrease in it. Well, 400%, if you decrease all of them, that's 100%. So that's kind of a misleading percentage. So make sure you understand that percentages, use them appropriately. So that's kind of just a quick intro to statistical and critical thinking. We want to kind of make sure we kind of look over that, kind of understand in this as we're kind of getting that introduction to statistics.